Okay, so good day everyone. So our topic for today, of course, is related to enterprise architecture model. No? So the main difficulty of an enterprise architecture model is its constant evolution. No? And consequently, its permanent update. No? Unlike building plans, which we can assume will remain stable over a very long period of time. So enterprise architecture models quickly become obsolete if they are not updated. So the organizations, the information system, procedures, business, and goals are constantly evolving, making it essential to rework models in order to reflect changes. So the structure described in the enterprise architecture model ultimately enable the enterprise to reach out of people, facilitating all transaction and interaction with them. So the system constituting the architectural elements of an enterprise are driven or driving these exchanges, and they are visible to people as tools in services to solve tasks and make decisions as information assets, communication channels, and workflow. And they take concrete form in physical and virtual spaces. So in personal conversation, phone calls, or web-based transaction, enabling people to interact with the enterprise. So it is a common practice to organize two-gap enterprise architecture model using a structure that resembles the viewpoints retained for the approach, as closely as possible. Okay? To give us more details about the topic, let us all welcome our presenter. Go ahead, sir. Muted ka, sir.
Sir, no audio pa rin po sa end ko, sir.
Structure, aesthetic. So, what is the Open Group Architecture Framework or TOGAF? So, it has origin in the DoD Technical Architecture Framework for Information Management or TAFIM initiative during the late 1980s to mid-1990s. This evolved into the TOGAF, which has been popular in the private sector globally. So TOGAF is an enterprise architecture framework that help define business goals and align them with architecture objectives around enterprise software development. So the TOGAF defines as a enterprise or any collection of organization that has a common set of goals. And the purpose of EA to optimize across the enterprise to open fragmented legacy of process into one integrated environment that is responsive to change and supportive of the delivery of the business strategy. So, SOA, or Service-Oriented Architecture, defines a way to make software components reusable and interoperable via service interfaces. So services use common interface standards and an architectural pattern so they can be rapidly incorporated into new application. So this remove tasks from the application developer who previously developed or duplicated existing functionality or had to know how to connect or provide interoperability with existing functions. So each service in SOA embodies the code and data requires to execute a complete discrete business function. For example, is checking of a customer's credit, calculating a monthly loan payment, or processing a mortgage application. So the service interfaces provide loose coupling, meaning they can be called with a little or no knowledge of how the service is implemented underneath or reduce the dependencies between applications. So control, objective for information and related technology or COBIT is an increasingly internationally accepted set of guidance materials for IT governance designed to assist in the implementation of effective IT governance throughout an enterprise. For an organization to be successful in delivering IT resources against business requirements, IT management should put in an internal control system or control framework in place. So the COVID controls framework contributes to these needs by making a link to business requirements, providing a set of business processes for IT management, identify the major IT resources to be leveraged. So this is our modeled in an enterprise architecture repository. So defining the management control objectives to be considered for each processes. So as you can see the diagram, the IT resources are the same as the current state and the future states of the enterprise architecture model. So likewise, in the main COVID diagram, the IT resources shown the center are modeled in the enterprise architecture repository. The enterprise architecture becomes the central repository for IT resources accessed by the COVID IT management process around it. So governance areas. So strategic alignment focuses on ensuring the linkage of business and IT plans, defining, maintaining, and validating the IT value propositions, and align IT operations with enterprise operation. Next is the value delivery. It is about executing the value proposition throughout the delivery cycle, ensuring that delivers the promised benefits against the strategy, concentrating on optimizing cost and proving the intrinsic value of IT. Next is the resource management. So it is about the optimal investment in and the proper management of critical IT resources, applications, informations, infrastructure, and people. So key issues relate to the optimization of knowledge and infrastructure. Next is the risk management. So it requires risk awareness by a senior corporate officer, a clear understanding of the enterprise's appetite for risk, understanding of compliance requirements, transparency about the significant risk to the enterprise, and embedding of risk management responsibilities into the organization. So performance measurement, so it tracks and monitor strategy implementation, project completion, resource usage, process information, and service delivery. Using, for example, balanced scorecards that translate strategy into action to achieve goals measurable beyond conventional accounting. So, business and EA goals. The following diagram illustrate how the enterprise strategy leads to business goals for IT. So, IT goals, enterprise architecture for IT, which are ultimately measured by an IT scorecard. Although these are very IT only view of enterprise architecture, which comprise both business and IT views, and it helps to understand the use of COVID with enterprise architecture. So, Sackman framework. In the early 80s, there was a little interest in the idea of enterprise engineering or enterprise modeling, and the use of formalism and models was generally limited to some aspect of the application development within the information system community. The subject of architecture was acknowledged at that time. However, there was little definition to support the concept. This lack of definition precipitated the initial investigation that ultimately resulted in the framework for information system architecture. So, although from the outset it was clear that it should have been referred to as the framework enterprise architecture, that enlarged perspective could only now begin to be generally understood as a result of the relatively recent and increased worldwide focus on enterprise engineering. So, the framework of enterprise architecture as it applies to enterprise is simply a logical structure for classifying, organizing the descriptive representation of an enterprise that are significant to the management of the enterprise as well as to develop the enterprise system. Manual system as well as automated system, it was derived from analogous structures that are found in the older discipline of architecture or construction and engineering manufacturing that classify and organize the design artifacts create over the process of designing and producing complex physical products. So the framework graphics in its most simplistic form depicts the design artifacts that constitute the intersection between the perspective represented in the design process, that is owner, designer, and builder, and the product abstraction. That is what the material is made of, how processed it works, and where geometry the components are uh, relative to one another. So who operating instruction is doing what work, when is a time diagram, do things happen, and why engineering design objectives do things happen. In the older disciplines, some other artifacts were observable that were being used for scoping and for implementation purposes. These additional perspectives are a labeled planner and implementer. and are included in the framework graphics that is commonly exhibited. So in the more recent framework graphics, the end result in the case of enterprises, the enterprise itself is also included to complete the classification structure of the descriptive representation as well as the end result. The framework as a classification structure and its most generic form appears uh, below. So the older discipline of architecture and manufacturing have accumulated considerable bodies of products knowledge through discipline management of the product definition, design artifacts. So this has enabled enormous increase in product sophistication and the ability to manage high rates of product change over time. Similarly, discipline production and management of enterprise definition. So it is the set of models identified in the framework for enterprise architecture. So it should be provided for an accumulation of a body of enterprises knowledge to facilitate enormous increase in enterprise application and accommodation of high rates of enterprise change over time. So although the framework for enterprise architecture or the Sackman framework is an application of framework concepts to enterprises, the framework itself is generic. It is a comprehensive logical structure for descriptive representation of any complex object and is neutral about the process or tools used for producing the description. So, like any good classification system, the framework is clean, normalize one fact in one place. There are no mixture in the structure. The classification is holistic, complete, and it's stable. The same classification on both axes has been employed by humanity for thousands of years, and it's not going to change for this reason. The framework is applied to enterprises, and it is helpful for sorting out very complex. So enterprises engineering choices and issues that are significant both to general management and to technology management.
Hello.
So in summary, the framework is simple. So it is easy to understand, nor technical, so purely logical. In its most elemental form, it is a five perspective. First is owner, designer, builder, bounded by scope and detail plus instantiation, the enterprise itself, and six abstractions. So what, how, where, who, when, and why. Anybody can understand it. Second is comprehensive. It addresses the enterprise in its entirety. Any issues can be mapped against it to understand their primitive or composition within the context of the enterprise as a whole. So third is the language. It helps you think about complex concepts and communicate them precisely with a few non-technical words. So fourth is the planning tool. It helps you make better choices as you never are making choices in a vacuum. You can position issues in the context of the enterprise and see a total range of alternatives. So next is the problem solving tool. It enables you to work with abstractions to simplify to isolate simple single variables without losing sense of the complexity of the enterprise as a whole. Next is the neutral. It is defined totally independently of tools or methodologies, and therefore any tool or any methodology can be mapped against it to understand their implicit trades-off and degrees of completion. That is why they are doing and why they are not doing. So lastly is the raw materials for enterprise engineering. The primitive models when operationalized for enterprise are the design artifacts required for enterprise engineering just like the drawings, functional specs, bills of materials, and etc. are the design artifacts required to engineer any physical object. So, if the models are specified by the framework were operationalized for a given enterprise, engineering design objectives like alignment, quality, integration, flexibility, interoperability, reusability, and could be an operating reality employed to accommodate complexity and optimize the enterprise. The model, if returned and maintained, would serve as a baseline for managing change. So these are the um, characteristic of architecture for anything. So architecture is not one thing. It is a set of things and in fact a set of 30 descriptive representations relevant for describing a complex object such that is can be created, uh, that is engineered, optimized so it meets its design objectives and relevant for changing. So this is true for enterprises just as it is true for buildings, airplanes, automobiles, bridges, supercomputers, battleship, semiconductor chips, or any other complex object. So that's for my report. Thank you for listening. Have a good day.
Okay, so again, during comprehensive exam, no, there are certain questions no related to TUGAP, no, related to what Sir Edward no discussed, no, and most commonly they were asking about the model technique, no, especially a while ago I've mentioned that making a model of a reference, no, the situation can deteriorate very quickly, no. So if analysts or architects do not trust, no, in the relevance of existing models, the pressure or deadlines may force them into rebuilding model, no, uh, ad hoc, no, focusing on the requirements of the moment. So which are even more short-lived, no. So worse still, maybe decide to do without models altogether in order to continue the actual realization of the of course realization of projects, no. So if this happened, the enterprise is back at square one, no, where a knowledge is neither controlled nor recorded but rather scattered across detailed realization, and this difficulty requires vigilant governance and significant involvement of the architecture board. So again, as I mentioned, no, the it is a common practice to organize TUGAP enterprise architecture model using a structure that resembles the viewpoints retained form the approach as closely as possible, no. And we discussed already about the UML and BMPN modeling tools that do not use the concept of viewpoints, that the model must be organized using packages, no. And again, by default, viewpoints span at least the four TOGAP architecture domains, no, the business, application, data, and technology. Again, the TOGAP architecture domains: business, application, data, and technology. So the separation of concepts and model is easy with regard to business application and technology architectures and is naturally supported by UML packages that are specialized for TUGAP. So the data architecture partially spans business architecture and application architecture depending on the level of representation used. So actually, we have two sub-packages are therefore created inside the business architecture and application architecture packages to support data structured or architecture. And this structuring is by no means mandatory. In particular, the definition of viewpoint specific to an enterprise can lead to different structuring. Let's say, for example, an additional viewpoint dedicated to system security could be investigated or envisaged. And the structure is then further broken down in a functional way relevant to the enterprise business. So the enterprise model, a compendium of the highest level of data and process model, is an enterprise architecture model. This is model that captures high-level business entities, yung BEX, and high-level business processes, yung BAS, that reflect the major reasons for the enterprise existence. So it's highly abstracted in nature and content. It looks at things from 50,000 foot level, and there is not a great deal of the detail, but the main subject areas are defined with the BEX, and high-level functions are defined within their BAS. Again, further external subsidiary models deal with the specification of data at the application level. So I think that's it for this topic, related to the TUGAP. Of course, we have Saxman model, and we have, of course, QBIT, SUA, yung mga available enterprise architecture model. It depends upon, of course, to the businesses if they wanted to adapt TUGAP or Saxman, but most commonly, especially right now, they are more preferred to use TUGAP. And again, the TUGAP enterprise, of course, is or framework, for the SOA, because an effective enterprise architecture is critical to business survival and success, and is the indispensable means to achieving competitive advantage through IT. So TUGAP is detailed method and set of supporting tools. Supporting tools for developing enterprise architecture. It codifies the good practice that was evolved in the work of enterprise and IT architects over many years. So it will help the architect to decide whether and how to use the SUA. So the TUGAP architecture development method, or yung ADM natin na TUGAP, breaks the complex process of architecture development into a number of simpler steps or phases in which the architect consider different aspects of the overall problem. So in TUGAP, we have a preliminary phase, we have architecture requirements management, we have the architecture vision, business architecture, we have, of course, information system architecture, technology architecture, opportunities and solutions, migrating planning, implementing governance, and architecture change management. So yun yung ng requirements management ng TUGAP. So on the other hand, when it comes to SOA reference architecture, they have nine layers. A while ago, I mentioned about the operational system layer. We have service component layer, services layer, we have business process layer, integration layer, quality of service layer, information layer, governance layer. And there are certain partitions and center for of excellence establishing the architecture team. And what else? When it comes to its application, we have meta model objects involved, like process, business services, and so on and so forth, no? And if you want to be more knowledgeable when it comes to TUGAP 9, I think you just visit the meta model with relationship updated with SOA extension. So I think that's it. Okay.